And this is 4-6, the alpha lesson. So we're going to start with this question. It's not at the end of the section, but it's kind of embedded in the section on page 255. This is what this is about. So it says, an observer is 70 meters south of a railroad crossing. All right. Here's the observer. That's 70 meters. It's not the scale that the observer would be going to. Then the railroad crossing is here. Okay? And he wants to train is eastbound, and it's going 60 meters per second. The train's going from west to east. How many meters per second is the train moving away from the observer 4 seconds after it passes through the intersection? These are the kind of questions that you see like in movies where people are intimidated by math. So if they're going 60 meters per second for 4 seconds, this would be 240 meters. Yes? And that you immediately think of something when you see 7240. I do it, believe me.
250.
Thank you, Eddie. Why?
That's triangles.
It's a Pythagorean triple where the side change of magnitude 10. So here's the thing is, this is the distance that the observer is in the train. But the train's moving. So when the train gets to here, that distance is greater. And then the train's over here, the observer's standing still. They want to know how fast is the distance from the person to the train changing at exactly 4 seconds. That's what the thing is. Okay? So we're not going to solve this problem today, we're just going to set it up. We're going to do the examples in the book that have to do with this type of question. So what are we told? Well, here's how we set this problem up. You have 2 options for later rates. One is dimensional analysis, and one is implicit differentiation. Some problems can be done either way. But you need to be aware of both techniques. So if I look at this thing in the context of dimensional analysis, I'm going to call this side of the triangle y and that x. That makes sense because it's vertical and horizontal. And I don't want to call this h for hypotenuse. I'll call it r. I don't want to call it h because that kind of confuses it with height, and then it look like a y diagram kind of makes sense. You got it? So you're being asked for the change in r with respect to time. That's what you're being asked to find. You have to identify it. You're being asked, yes? Then you are given something. You have to be given something to help you find that. So think about what's in the question, just tell me what we were given. Which is what? What were you given?
Y for 70.
Correct. But in terms of the rate, what rate were you given? You were given the rate that the train's travel. So they gave you the x dt. Make sense? That was given. They had to give you something you saw. So now what? Dimensional analysis, If I multiply what I was given, ready? I want dr dt, so I need an r. I need to get rid of the x. If you multiply this by what you were given, the dx is going to reduce and will give you what you want. Now, Eddie brought something up and he said, I have a triangle. So you could do this. You could say x squared plus y squared equals r squared. And take the derivative with respect to time of the whole thing. This is dimensional analysis. This would be implicit differentiation. Either way, we take you to the answer of the problem. Now, today, we're going to tell you. When we get to the beta lesson, which you're going to be doing from home, when we get to the beta lesson, I did this problem both ways. Today, we're going to focus on dimensional analysis to do the questions in the book. Okay, and then what's going to happen on the beta lesson is we'll go through this problem, both perspectives, and I will show you what a related rates question looks like on a previous AP test. Like we're getting close now to where we can start rolling out the FRQs in the past and show you where to find them and to look at the questions and the answers. Okay, we're coming to the end of differential calculus. So here's example 2. There's a picture on page 247. You have this balloon. So here's the picture, right? And the question says, the hot air balloon is going straight up. And it's 500 feet from this spot on the ground, 500 feet horizontal. So it's a triangle like the question when you first started. Okay? At the moment this angle right here is pi over 4, we're telling you the change in the angle. How fast is the balloon going up? So think about this. As the balloon goes up, this angle gets larger. Make sense? The balloon is here, now it's up here. So this angle is greater than pi over 4 when the balloon gets higher. We're saying specifically when the balloons, when that fade is pi over 4. So we're here. I'm saying they want dH dt. See, when they labeled the picture, they label what we call y in the problem. They labeled as d, so we'll simply put it in. We want to change the height of perspective time. That's what they asked for. What did they give you? They gave you the change in the angle of perspective time. He told you how fast that theta, that angle, was changing. So this was given. That's what you're looking for. So to set up the dimensional analysis, what has to happen? I got to introduce the DH, and I got to get rid of the D theta. Because if I set it up this way, and you multiply these two, the D thetas would reduce, and you would get DH over D2. So the point is, let's find DH D theta. And if we find it, let's multiply by what was given. Did you know? Well, we can start with SOHCAHTOA. Let's try this backwards, but the tangent is opposite over adjacent. So the tangent would be h over 500. Solve for h. 500 tan theta. Let's clear the fraction. What's the derivative of that? Derivative of tangent, secant squared. Now make sure you understand this. You want the derivative of this. You can use the product rule if you want. You don't need to. You would have first term 500 times the derivative of tangent is secant squared. Plus, the derivative of this term would be 0. You're left with that. You don't need to use the product rule. Doesn't make it wrong. But you can just bring this coefficient out front. So you have DH d theta is 500 secant squared. Now, right? We're going to go to the answer. But the answer is secondary. When you do these problems, if you don't do this part correctly, everything you do after that is spinning your wheels. You need to take your time and organize the information and set it up correctly. Because if you were to set this problem up incorrectly, you can do a lot more calculus than we get here. So, what I want is when theta is pi over 4. What have you got? Well, I got this. And pi over 4, cosine and sine are both root 2 over 2. You want secant. Secant is reciprocal with cosines. So pi over 4 secant is 2 over root 2. I have 500 times 2 over root 2 squared, which gives you 4 over 2, which is 2 times 500,000. The given information was d theta over dt. The change in the angle with respect to time is 1400. So you have 1,000, which you reduce with 100. If you do 10 times 14, you get 140. 140 what? Ready? It's a rate. You have to have the rate of your answer. You're going to get penalized. If you have a numerical answer, you'll get partial credit. If you want full credit, it's 140 feet per minute. Right? So, this is the answer, which is secondary. And we're concerned with this. Here's how we set it up. So I'll leave that up there as we pause the video and send you to number 11. All right, so here's 11. We wrote it up here. All right. You were given dV, dt, you want dr, dt. To get there, you need to multiply by dr, dt. Now look over here. There's no dr what I have, so we got to introduce it. There's no dB where I want, so they agree. You might think, okay, we're not going to take solid divide for all. There you go. Just find dB dr, take the reciprocal of it. So we're here. That's what the volume is. Here's the derivative by the power rule. The reciprocal would be this. Because we want the RdB. They tell me at the instant R is high. The given information is 100 pi. The 100 is reduced, and you can get one what? 1 foot per minute. For surface area, here's the SDR, right? You want the SDT. So I took my answer that I had up here, dr dt. The dRs are reduced, and I would get the SDT. So I multiply the SDR, which is 8 pi r, times the answer to A, which is 1, you get 45. 45 what? Feet squared per minute. So this area. Don't omit the rate. Example 4 is a conical tank. So the picture's on page 248. Right? You're given the water runs into the tank at this rate. So you're given dB dt. They want to change in the height, dH dt. So dimensional analysis is going to multiply by dH dV, which would be the reciprocal of the change in height with respect to h. Except this example is more challenging because you've got two variables. So if you have two variables, you either have to rewrite one of them in terms of the other, which is how it's done here, or do this by implicit differentiation. So to do this implicitly, you would say the change in volume with respect to time would equal 1/3 pi, which is the constant. Now you've got the product rule here. R squared, first term, times the derivative of this, which would be 1 dH dt. Plus 2R dr dt times h. That would be the implicit differentiation approach to this. This solution based on differential analysis. There are the two branches you have. You decide how you want to approach the problem. Some problems you can do like, but you can look at your strength.
Like you said, some problems you do it either way. What do they do? What do you do?
What's more? The problem that we started with, we will do that on Monday from both perspectives. The problem, I'll look at the problem is on a SAT test, and I'll show you that. There's no, like, I can't tell you this is how you do it. Now what? If I'm going to do this problem by dimensional analysis, you can't do it with two unknowns. So they told you the ratio part of H is 5 to 10. I've got an R and H in here. So I can solve for what R equals, V equals 5/10 times H, for H over 2. So I put H over 2 where there was an R. And what that gives me? H squared over 4. 4 times 3 is 112 pi H cubed. And then I can do the derivative of V with respect to H, which is the reciprocal of what you want up here. Okay? So, like I said, the answer is second. That's going to be it for the alpha lesson.